Welcome to This Explainer. You know, we hear a ton about AI brains and large language models these days, but have you ever stopped to wonder how a computer actually interacts with the physical space you're sitting in right now? Today, we are absolutely unpacking how artificial intelligence perceives the real world. Let's break down this massive, invisible network of sensors quietly operating all around us.
Literally, close your eyes for just a second. I mean it, just for a second. What can you hear right now? Maybe it's the hum of your computer, some traffic outside, or just my voice. Now open them. Think about all the colors and geometry you're taking in. We human beings process this wild, continuous stream of sensory data without even breaking a sweat. And to really grasp how AI works, we first have to appreciate just how incredibly complex our own human baseline is.
Section 1. Our amazing human senses. It's pretty incredible how we naturally use our eyes to see shapes and colors, and our ears to effortlessly hear music and voices.
Moving on to Section 2, AI's digital eyes and ears. Okay, let's dive into this. So obviously, a machine doesn't have biological eyes, right? It relies on digital cameras. But here's the thing, just capturing an image is definitely not the same as understanding it. Take a gaming console camera, for example. It's not just passively recording a flat video of your living room, it's actively using computer vision algorithms to map out your skeletal movements in real time so you can control a character on screen. It is literally perfectly mirroring how our own eyes translate light into actionable information.
And we can draw a pretty brilliant parallel with our hearing, too. Our human ears take in sounds and our brains just automatically assign meaning to them. AI microphones, well, they're basically just recording raw audio waveforms at first. The real magic happens when the AI uses natural language processing algorithms to actually interpret all that acoustic data. So when you yell out to a smart speaker, it's not just hearing your voice. It's instantly processing those audio waves to figure out exactly what you want, so it knows precisely when to play your favorite song or, set a timer for your pizza.
Section 3. Feeling and moving around. Because AI perception goes way beyond just seeing and hearing.
Now, what's really interesting about this slide is how we can categorize these extra sensors that allow machines to safely interact with their surroundings. For AI to navigate our physical spaces, it needs a pretty complex physical awareness. Think of it like a mechanical nervous system. You've got touch sensors that give tactile feedback, like how a robot vacuum bumps into a chair and physically maps out your living room by noting mechanical resistance. Then, on the flip side, you have motion sensors detecting shifts in infrared energy, so they know the exact second someone walks by to trigger a hallway light.
Which brings us to Section 4, the smart doorbell story.
Let's see how all these isolated data collection sensors actually team up and work together in the real world. Imagine this everyday scenario. Step 1. A visitor steps up to Grandma's front porch. Step 2. The doorbell's camera and mic instantly wake up, capturing both visual and audio data. Then, Step 3. All that raw data gets fed straight into a localized AI algorithm that quickly scans for human shapes and voices. Finally, Step 4. Boom! It pushes a notification right to Grandma's phone saying someone is at the door. Now, the doorbell doesn't actually know the person, but its sensors and algorithms successfully recognize the pattern of human presence. Pretty neat, right?
Section 5. Why AI fairness matters. This is where things get really serious.
So the crucial point is algorithmic fairness. Honestly, understanding the mechanical nuts and bolts of these sensors is just the foundation for a much bigger conversation about responsible data usage. If an AI doorbell or a security camera is going to see and hear us out in the real world, it absolutely has to do so impartially. Since these AI models learn heavily from massive sets of historical training data, it is totally vital that we train them on incredibly diverse sets of information. That ensures they can accurately recognize people no matter their appearance, skin tone, or accent. It's about keeping the system equitable for literally everyone who interacts with it.
Now that you've got a handle on exactly how artificial intelligence mechanizes human perception, the big, ultimate question is this: how do we guarantee these systems treat everyone fairly? The machines are already out there, sensing the physical world around us, but it is entirely up to us to program their ethics. So definitely think about that the next time a motion sensor magically turns on a light for you. Thanks so much for joining me for this explainer, and keep questioning the tech around you.